So again, in this chapter, we are talking about thermodynamic cycles and processes. So we have 4 points that we need to cover in this chapter. So again, we started with classifying thermodynamic cycles. We start with talking about heat engines, and when we start talking about the power cycles or heat engines, we started with the ideal one, which is Carnot cycle. And then we have talked about also real heat engines. So for real heat engines, we talk about Rankine cycle, and we saw the modification that we can do to increase the efficiency of Rankine cycle, like reheat Rankine cycle or generative Rankine cycle. So we explained each one of them. We showed the equation that we will use to analyze the energy in each one of these cycles and how can we calculate the thermal efficiency of each one of them. Today we will talk about the refrigeration cycles. And again, similar to this one, so we need to know how can we analyze each of the components from which this cycle consists of, and this will lead us to analyze the overall cycle and calculate its efficiency. So we start the discussion about the refrigeration cycles. So if you remember when we start talking about the second law of thermodynamics, this was in the previous chapter. So we said there are several statements that can describe the second law of thermodynamics. One of them is that if you have work, so this work can be converted into heat. So if you have a fluid and you mix this fluid, so you can find the temperature of this fluid will increase. But if you increase the temperature of this fluid, so you cannot obtain a work. So work cannot be obtained from work. And we said that we need special devices to obtain work from heat, and these devices are the power cycles that we described in this chapter. One of the other statements of the second law of thermodynamics is that heat cannot be transferred from low temperature to high temperature. Heat transfer always happens from high to low temperature. This is the spontaneous direction of heat transfer. But if you want to transfer heat from low temperature to high temperature, so also in this case, you still need special devices. And these special devices are called refrigerators or are called heat pumps. So heat pumps and refrigerators, these are special devices. We are using these devices to transfer heat from low temperature to high temperature, which is not the spontaneous direction of heat transfer. Okay, so refrigerators and heat pumps, they almost the same device, the same components, maybe the same working fluid, the same flow direction, but only the objective is different between each one of them. And this means if we have like a refrigerated space, if you have a space, if we have a system at low temperature, and your objective is to keep this system at this low temperature, so your device is called refrigerator. So the objective of refrigerator that to maintain a refrigerated space at low temperature, and this happens by removing heat from this system, from this low temperature system. So this is the objective of refrigerators, that we need to make cooling of whatever we have. If the objective is to maintain a heated space at high temperature, so again, now your device is called heat pump. So we have refrigerators, we have heat pumps, they are the same thing. They contain the same, consists of the same components, but only the objective is different. So if your objective, if you have a low temperature space and you want to keep this space at this low temperature, so now you are having a refrigeration cycle, or it's called the refrigeration cycle. So the word, it indicates to the objective of your cycle. If you have a heated space at high temperature, and you need to keep this space at this high temperature, so now your cycle is called heat pump. Okay. So if we're going to see this diagram here, so this diagram, so this is like a refrigeration system, and this is a heat pump. So again, all these components are almost the same. And we have some warm environment, and here we have cold environment. In both systems, in refrigerators and heat pumps, you have work are adding to the cycle. So you have work are adding to the cycle. So here the input is work. So this is one of the inputs. Another input is QL, and if you remember the nomenclature, we said QL, this refers to the amount of heat transfer at low temperature. So you are extracting heat from the cold environment and you are adding this heat to the working fluid in both of them. And then you have warm environment and you are releasing heat to this warm environment to keep it warm. So this is the whole idea. So we have like work added to the system or added to the working fluid. At the same time, you have cold environment and you are extracting heat from this cold environment to keep it at low temperature. And at the same time, you have high temperature environment, high temperature space. And what you are doing is to reject heat to this high temperature system or high temperature space to keep it like heated at this high temperature. So if your objective is this QH, if this is your objective, so your objective QH that you release to the warm environment to keep it warm or to keep it at high temperature, so this is a heat pump, HP. But if your objective is QL, the amount of heat you are extracting from the low temperature system or the low temperature space to keep it cold, so this is the refrigerators. So again, almost they are the same thing. Everything is the same. So both of them, you have warm environment that you are rejecting heat to this warm environment. Both of them, you have low temperature environment that you are extracting heat from it. Both of them, you have work you adding to the working fluid in the heat pump and in the refrigerator. But one of them, QH, this is your desired output. QH, the amount of heat you add to the high temperature system or high temperature reservoir to keep it like at heated temperature. And one of them, the objective is the amount of QL that you are extracting to keep the low temperature space as cooler as possible. So if QH, this is your desired output, so your cycle is called heat pump. If QL, this is your desired output, so your cycle is called refrigerator. Clear? So as you said, they are the same. Everything is almost similar except the objective. Clear? Any questions? Any questions? Okay. If we see the components for each, any one of them, so we have almost the same thing. We have boiler, we have condenser, we have compressor, and we have throttling valve, or we may have turbine. Almost the same components of power cycles. Turbine, compressor, boiler, condenser. Turbine may be replaced by throttling valve, and we will explain when this may happen. Okay, but if you see the like the direction of or the differences that we have here between this and power cycles. If you remember, usually in power cycles, we have boiler. This was the unit that operates at high temperature. But here in refrigerator and heat pump, the boiler is operating at low temperature. So here we have this boiler at low temperature. But the condenser is operating at high temperature. And this is one of the differences between refrigerators and power cycles. So if you remember, in power cycles, we have boilers at high temperature, and we have condensers at low temperature. Here we are flipping it. The boiler operates at low temperature, the condenser operates at high temperature. If you remember also in power cycles, the outlet from the boiler was going to the turbine, the outlet of the turbine go to the condenser go to the compressor, and the compressor go to the boiler. This was the direction of power cycle. But here, if you see the direction, it's almost reversed. So the boiler outlet go to the compressor, then go to the condenser, then go to the turbine or the valve, then return back. So the direction of the working fluid is also reversed. So refrigerators or power cycles, they are refrigerators or heat pumps, exactly they are power cycles, except everything is reversed. So the boiler at high temperature there, here the boiler at low temperature. Condenser there at low temperature, here condenser at high temperature. The flow direction of the working fluid in power cycles, so the boiler outlet will go to the compressor, then condenser, then turbine. But here in refrigerator and heat pump, so the outlet of the boiler will go to, so in power cycles, the outlet of the boiler will go to the turbine, then condenser, then compressor, then boiler again, but here the direction is reversed. So what is coming from the boiler will go to the compressor, then the condenser, then the turbine, and then to the boiler. So everything is almost reversed. And by reversing all of these things, the direction of the working fluid, reversing the temperature of the condenser and the boiler, then we have like different objective happening. Clear? So the first one, again, power cycles, its objective to obtain work, but here the objective is to like transfer heat from low temperature to high temperature in order to have a system or a space at lower temperature, keep it cold. We have a system at high temperature, we keep it heated. Clear? Any questions? Okay. So similar to power cycles, we have efficiency. Here the efficiency is not called efficiency, but it's called coefficient of performance. It's another way to represent the efficiency. And the coefficient of performance of refrigerators and heat pumps, it's ratio between what you need to obtain from this cycle divided by what you are giving to this cycle. So always the coefficient of performance or efficiency is what you take from the cycle divided by what you are giving to this cycle. So here what you are giving to this cycle is work. This is in the refrigerator and heat pump. So we have work inlet to this to the working fluid through the cycle. This is your input. And what is your output? Again, your output, this depends on what, if you have refrigerator or if you have heat pump. So if you have refrigerator, your objective is the cooling effect, or Q, the amount of heat that we are taking at the low temperature part of the cycle. If you have heat pump, so the heating effect, this is your objective, so QH, the amount of heat that you are like releasing to the high temperature system. So always in heat pumps and refrigerators, they have the same input, they have work in, but if you are analyzing refrigerator, so your objective is QL. If you are analyzing heat pump, your objective is QH. So this is why we can say coefficient of performance of refrigerator is QL divided by inlet work. Coefficient of performance of heat pump, it's QH divided by inlet work. Okay, so the same equation, the same general equation, but the terms that may differ because of the objective of refrigerator is different from the objective of heat pumps. Okay, and if you remember from first law of thermodynamics, we have QH is QL plus net work. So if you substitute this equation and compare coefficient of performance of both of them, always you will find that coefficient of performance of heat pump will be more than coefficient of performance of refrigerator. So if you have a system and you need to keep it warm, so this will be like consume less energy, or the cycle will be more efficient than if you need or if you have a low temperature system or a space and you need to keep it cooled. Okay, clear? Any questions? Any questions? Okay, so this is the whole idea. So now, just to summarize it, so if you have like two systems, one at high temperature, another one at low temperature, so always heat will be transferred from high to low temperature. If you need to make the opposite direction or allow heat to be transferred from low to high temperature, so you need a special device, such as refrigerator or heat pump. So this is a cycle, have the same components of power cycles, except everything is reversed. The direction of the working fluid reversed. The temperature and of boiler and condenser, they are also reversed. So by this reversing, then we can allow heat to be transferred from low to high temperature. So this cycle is called either refrigerator or heat pump. Okay, they have the same component. Almost everything, they are the same, except the objective. So refrigerator objective is the amount of heat that you remove from the low temperature system to keep it cold. So the cooling effect. This is the objective of refrigerator. But in heat pumps, the objective is the heating effect, the amount of heat you are releasing or giving to a hot system or a hot space to keep it at high temperature. How can we calculate efficiency? Efficiency of refrigerator is QL divided by inlet work. Coefficient of performance of heat pump is QH divided by inlet work. And these like two operating mechanism are not the same, even they don't have the coefficient of performance. So always you will have, if you operate your cycle as a heat pump, you will get high efficiency than if you operate it as a refrigerator.